Good morning, students. My name is Jawad, and today we will be discussing force and Newton's laws of motion. So, today we will discuss what is force and what are the Newton's laws of motion. Actually, Newton made a systematic study on force, and which is formulated in the three laws. So, those three laws are known as Newton's laws of motion. So Newton's laws of motion is formulated by Newton, which is actually explains the forces or which gives the detail of the force. So first we will be discussing something general about force. Then we will be going towards the Newton's laws of motion, which is the core of the subject actually. So what is force? We have already learned that force is a push or pull. So force can be applied in the form of a push or pull. So in order to push or pull, there should be at least two objects. One is that which pushing, or that the other one is being pushed. So force is the interaction of two or more bodies. In order to apply the force, there should be at least two bodies. So force is the interaction of two or more bodies. And if you are considering a lemon, and if we are squeezing the lemon, we can get the juice out of the lemon. So while squeezing the lemon, the shape of the lemon gets changed. So what we are applying the force. So what is happening, or what is the effect? The effect is nothing but the change of the shape. And similarly, if you are pressing the sponge, the shape of the sponge gets changed. If you are pressing a stone, will the stone be get changed? Will the shape of the stone be get changed? Obviously not. But we can assume that there may be a tendency in the stone that the shape of the stone may get changed. So we can tell force is that which changes or tends to change. In the situation where we are pressing the stone, the shape is not changing. So we are assuming the shape tends to change. So force is that which changes or tends to change shape, size and volume of the object. So if you are applying a greater force, the volume of the object can also be changed by force. So that is one of the effect of force. Now the other one is, if you are considering a ball which is at rest, so we can say it is the state of rest. So the ball is in the state of rest. Now we are kicking the ball, so the ball get moved. So we are changing the state from rest to motion. So now the ball is in motion while kicking. While kicking, we are applying the force. So the force changes the state of rest to state of motion. Similarly, a moving ball can be stopped by applying force. So there also we are changing the state of motion to state of rest. In the both situations, the first situation we are increasing the speed. Before kicking the ball, or if the ball is at rest, the speed is 0. Now after kicking the ball got some speed, so we are increasing the speed. Okay. In the second situation, we are actually reducing the speed. So the speed is changing by applying the force. When the force is applied, the speed of the ball is getting changed. Also, we can change the direction of the ball by applying the force. Consider if the ball is in motion, we are applying some force so that the ball may get deviated, or the direction may get changed. So the state of motion or state of rest can be changed by applying force. This is called, actually, we can change the state of motion of a body, meaning we can increase the speed, or we can decrease the speed, or we can change the direction of the body. We can change the direction of motion of the body. So we can say state of motion of a body is changed when a body increases its speed or decreases its speed or changes its direction. by applying force. So by applying force we can change the state of motion of the body. So there are two effects we are actually written here. One is we can change the force that may changes or tends to change the shape, size and volume of the body, or it also changes or tends to change the state of motion of a body. State of motion of a body is changed if its speed changes or direction changes. Now there are certain types of forces. Some forces I am including here, so we can discuss this one. So first one, muscular force, the force that which we apply to move an object or even to move ourselves. We are applying actually muscular force. So muscular force is make use of the animal makes use of the muscular force. Then electrostatic force. Electrostatic force is due to the charge of the particles we are having the force, which is known as electrostatic force. Then electromagnetic force. Electromagnetic force also because of the charge, but here the charge is in motion. When the charge is in motion, the magnetic field also be produced. So when the magnetic field is produced, the magnetic field interacts. This magnetic field, because of this magnetic field, the force can be experienced, which is known as electromagnetic force. The fourth and fifth one, strong nuclear force and weak nuclear force, are related with the nucleus. If you are considering an atom, there is a central core which is known as nucleus. So in the nucleus there are many particles togetherly known as nucleons, for example neutron and proton. So these nucleons are held together because of the strong nuclear force. So the nucleons are held together because of strong nuclear force. The weak nuclear force also experienced in the nucleus, but in certain conditions or certain situations which you will discuss in, which you will learn later. Now next one, gravitational force. Gravitational force is nothing but the earth attract all the objects towards its center. Not only the earth, all the objects in the universe attract each other towards its center. This force is known as gravitational force. So the apple falls towards the earth, and that is because of the gravitational force. We are also being pulled by the earth. That is an example for gravitational force. Okay. Now we will be discussing the relationship between the change of state of motion and the first law. So first law is deeply related with the state of motion of a body. Okay. So we are just we have to consider the first law. Before explaining the first law, here itself I have written something. See, muscular force, in order to apply the force ourselves, we need to touch it or we need to contact it. So the contact is needed to apply the force. Such force is known as contact force. If contact is not needed for applying the force or for experience the force, then such forces are known as non-contact force. If you are considering the gravitational force, the apple falls towards earth not because the earth has touched the apple, but earth has pulling the apple without being touched. So that is non-contact force. So nuclear force, gravitational force, electrostatic force, electromagnetic force, all these forces are an example for non-contact force. Now we can discuss the first law. Even before discussing the first law, I have to discuss something on external and unbalanced force. External, that is something outside. So for example, you are moving in a vehicle and suddenly the vehicle got broken down, and that driver told you to push the vehicle so that the vehicle may get started. So how you are going to push the vehicle? Whether you push the vehicle while you were inside of the vehicle, or will you come out from the vehicle and will you push the vehicle from outside? Obviously you will push the vehicle from outside so that the vehicle may get moved. So in order to change the state of rest to state of motion, you are applying the external force. This is called external force. Okay, so external force, and I hope you understood the external force. If you are applying the force within the system, within the body itself, it is called the internal force. Now balanced force and unbalanced force, I have to talk. For example, there is a ball. If I am applying a 5 unit of force in this direction, the ball will go in this way. Okay. Now, on the other hand, if I am applying the force in this direction, the ball will go in this direction. That is because of the directional property of the force. Because force is a vector quantity. Force is a vector quantity, so it has both the strength as well as the direction. Strength or magnitude. That is the size or strength we will call as the magnitude of the force. So here the magnitude of the force is, for example, 5 units towards the right. So that's what the force is. That's what the force here. Now, if I am applying the force in this direction, it will move in this direction. If I am applying the force in this direction, it will move in this direction. Now, if I am applying 5 units of force in this direction and 5 units of force in this direction, that is opposite direction, I am applying same magnitude but opposite in direction. Will the ball be moved? If I am applying the force 5 units here and 5 units from here, so that the force get cancelled. Okay, that is because force is a vector quantity. So here, even though force is applied, the net force, the total force is actually 0. So we can say the force is balanced. Here the force is balanced. If I am applying a 5 unit force in one direction alone, then force is not balanced, or it is we can say there is a net force, or we can say there is a unbalanced force. If force is not balanced, that is unbalanced force or net force is applied. So if I am applying a 5 unit force in this direction alone, then I am giving external force. I am giving the force from outside of the ball, so that is external force. And here the force is not balanced because the net magnitude is 5 units. So that is unbalanced external force. So we need the unbalanced external force to change the state of motion of a body. Now again, if you are looking at the first law, it will be more easy for you. Every body continues its state of rest or of uniform motion in a straight line unless compelled by some external force to act otherwise. I am reading one more time. Every body continues its state of rest or of uniform motion in a straight line unless compelled by some external force to act otherwise. So here we are splitting it and we will synthesize it. So every body continues its state of rest. If a body is at rest, it will continue to be at rest. That's the meaning. Or if the body is in uniform motion, meaning equal distances in equal intervals of time, so distance by speed at any interval of time will be constant. So that is, speed is constant. So uniform motion in a straight line. In a straight line meaning direction is not changing. So we are specifying the speed is constant and the direction is not changing. So speed with the direction is nothing but velocity. Here speed is not changing, direction also not changing. So the velocity is constant. So there are two situations. If every body continues its state of rest or uniform motion in a straight line, we can simply say, or it will move with constant velocity, okay, unless compelled by some external force. Some external force meaning external unbalanced force. Unbalanced the force is unbalanced as well as external. Some meaning unbalanced. So unbalanced force to act. So unless a force is acting on the object, which force? Unbalanced external force. The object will continue to be either at rest or in uniform motion in a straight line, meaning it may move with constant velocity. If a body is moving with constant velocity, then it will continue to move with constant velocity until and otherwise we are applying some external force to it. Or if a body is at rest, it will continue to be at rest unless and otherwise we are applying some external force into it, or unbalanced external force to it. Okay, now I hope you understood the two situations. If the net force is 0, the body can be either at rest or the body can move with constant velocity, meaning same speed in a constant speed in the same direction. The direction will not be changed, and direction will not be changed as well as the speed will not be changed. Now imagine if we roll a ball in the ground, over the ground, the speed of the ball gets reduced as the time passes. So here speed decreases. So we can assume that some external force is acting while the ball is rolling. Actually the external force here acted on the ball is nothing but frictional force. So since the frictional force is acted on the ball while the ball is in its roll, the speed of the ball gets reduced. Okay, if there would have been no friction, if the surface was frictionless, then the ball will move with the initial speed and in the same direction. Okay, then if the surface is frictionless, it will move with the same speed. Now again we are summarizing. The body can be either at rest if force is 0, or the body can be moved with constant velocity. If the body is at rest, or if the body remains at rest, then the acceleration is 0. Velocity, change in velocity by time is 0. So acceleration is 0. Or if the velocity is constant also, acceleration is 0. Acceleration is nothing but a change in velocity divided by time. So change in velocity we will be getting 0. 0 by time is 0. So in either cases acceleration is 0. So when force is equal to 0, acceleration is equal to 0. That is the first law. The summary of the first law is when f is equal to 0, a is equal to 0. And we will be telling if f is 0, that is if external force is 0, we say the body is in equilibrium. So the body can be in equilibrium when f is equal to 0. So a body is in equilibrium if the body continues to be at rest or if the body is moving with constant velocity. So if the body is at rest, we will be telling static equilibrium. If the body is moving with constant velocity, we will be telling dynamic equilibrium. Okay, thank you.